So now you're next. What's next?
Well, he doesn't want us to have a wire from the seat. Like he doesn't want that wire from the seat to our circuit board.
Why?
He said it's messy.
Yeah, but what he wanted to be wireless or something? What are you talking about doing?
No, we just wanted like an area on the desk. Somebody can just
and if somebody touches it, it'll send.
Yeah, but that means the person got to keep their hand on it for it to be active, unless you want to touch it. And then when you remove your hand, the temperature will go back to the ambient temperature. And then what? You see what I'm saying? Because then it's not going to know you're there anymore. How's it going to know when you left?
I think just as long as it's a difference in the circuit or a difference in the temperature from both circuits, definitely you just want it to wake it up.
Well, yeah, but that's what I'm saying. When you touch it, it'll know you're there. And then when you remove your hand, after the thing reaches the room temperature, it won't know you're there anymore. And so let's say that somebody's talking to their friend or whatever. The thing will automatically shut the computer down unless the computer can only be shut down by the user.
I think, like, the way I was thinking about the program on the A to D converter would be like, while the temperature is not greater than X amount of degrees between the two circuits, then keep going through this and keep the computer at a sleep mode. But once it does get greater, then wake it up, and then that's it.
So it'll wake up, and then the user is the only person who can shut it down.
Right.
Okay. Because if it automatically shut down, if the person is talking or whatever, it'll automatically shut down.
Right. I didn't want it to be like, I didn't envision it being the computer being controlled by that circuit alone. It would just be like, mouse click, okay, that's it. That's our scene design project right there.
Okay.
Yeah. Not computers on while heat is greater than X amount of degrees. Computer goes off when temperature, you know what I'm saying? Dips below that.
I guess I don't quite understand why is the seat sensor such. Why does that bother him so much? I don't.
You guys have fun. I'm just happy to get out of there.
Yeah.
Maybe he's just bothered by something touches my behind. Oh, this is bad.
Yeah.
Because I was thinking we're gonna have it embedded into the seat.
Well, it can't be embedded. It's got to be very close to the surface.
Okay.
Because wood is a relatively good insulator, which means that it takes a long time for heat to go through wood.
Okay.
So that means if you sit on wood and you got the thing on the bottom of the wood, it may take a couple of hours for the heat to go all the way through the wood and come back to the other side. And that means it's not going to know anything. So it's got to be at a place where it's very close to the surface. Unless you got something like a good thermal conductor, like metal. Like if you had like metal there and then the thing was connected to metal on the edge, then that will work. Because metal is a good conductor. Therefore, if you sit on it, the temperature of the metal is going to rise very rapidly, which will then increase the temperature of the sensor, and then the circuit will know that you're there.
Roger.
Okay.
So we're gonna have to build something on the desk, a sensor on the desk, because he doesn't want any wire.
Yeah, but I mean, I thought it was your project. Why is it? How can he sit there and tell you how you're supposed to do it? It either meets his requirements or it doesn't. But anyway, I guess you got through it. That's all that matters. Right?
Yeah.
We just want to congratulate. I don't have anything.
See, that's the wrong attitude, man. You guys got to change things. Although, I don't know if I told you guys, but in the future, Dr. Gray's going to be teaching scene design, so it's going to be different anyway. So hopefully a lot of the problems I'm talking about, because I think Dr. Gray will probably put an example of what he wants for everything versus this stuff where you're kind of up in the air, you don't really know what this guy wants. That's really bad. And to me, also, I like to see projects where you can have something that's almost all software or something, because a lot of designs are not hardware. You buy the hardware, you integrate it, and then you write the software. So everything is not transistors and resistors and capacitors. That's just not the way everything is done in the real world.
So on the desk, we're just gonna have a thermistor on the desk, and they had to hold on to the thermistor.
Well, what you can do is, if you could have like a little metal plate, and that metal plate could, let's say it's the size of, I don't know, maybe it's like maybe it's like 2 inches, about 2 inches. If they touch that plate, the temperature of that plate is going to rise rapidly. And as long as the thermistor's making contact with that plate, then it's going to, the thermistor in the person is going to be at the same temperature.
So do they have to hold on to that?
They're going to have to hold on to it until the temperature rises. That's one of the problems with what you're talking about. I'm sure you guys noticed, even when you touch it, the temperature didn't rise instantaneously, right? Because there's a thermal gradient, the difference in temperature between you and this thing, and it takes time for the heat to actually to conduct from your body into this thing.
It took like 5 seconds for it to go to a constant. 0.73.
So they would just hold their hand or fingers there until it powers on.
Right, but
Right.
I think that metal, putting that metal around will speed it up too.
Yeah, but if you really think about it, that's still inconvenient because somebody has to sit here and do this for a certain amount of time versus just sitting in the chair
Right.
and the thing just knowing you're there and then bringing up the computer.
I mean,
That just seemed like to me a better solution.
If we could do it, I'll just remotely. That would just be like he don't want no wires going to the chair. That's what he was saying. He said that would be like messy, unappealing, blah blah blah.
Mm-hmm.
And he was trying to talk about doing it remotely. Like, no, this is our design. Remotely, like if we tell you we're gonna do it remotely, then you're gonna be looking for us to do it.
Some wireless thing.
Yeah, something wireless when we present it, and that's not gonna happen. Like, this is what we're gonna do. So if we have to put it on top of the desk for us to get, you know what I'm saying, to make it possible, and that's what we're gonna do. I'm not gonna tell you that I'm gonna do something else and then not do it, and
Right.
then you be holding us to that expectation.
Right. Okay.
Donovan, what time is it?
10:48.
Okay.
So what you guys got to do next? What's the next step
Well-
in the process?
Get into the scene design thing and start building it.
Yeah.
Okay. So you ordered some of your parts.
No.
Plus a lot of the parts are already
Yeah.
here, right?
Yeah. I have all the parts that we need.
Okay. So you might as well start building it now.
Yeah. We're gonna build it on Sunday.
And what I was telling you, and I'd like to suggest to you too, you know you guys have these really long wires, you really need to stop making the wires really long. And I know this might ruin the component, but you need to cut the resistance like really short.
Cut the
Yeah, so it looks like stitches in fabric. You know how it'll come up and then go back down versus coming all the way up like this and
making it neater.
Yeah.
Yeah.
I think we was doing that just because I had no idea what I was doing. So if I had to change something, you know what I mean, or use it somewhere else. But I feel I
Well, see, because the way you had it, the problem with that is that it could work because it's not real neat. One of the wires would come loose and then it start working and you don't know where it is.
Okay.
While if you do it more neatly, then the odds of it popping up is very low.
Okay.
Yeah. So, I still hate the fact that he don't like the thing with the.
Yeah.
But anyway.
Eubanks built it already, too. That wire that I showed you yesterday. So.
But anyway.
Yeah.
So when do you guys have to turn in this thing?
21st
Of
November.
November?
Yeah.
Do the 26th.
Wait.
Monday the 27th.
Okay.
So basically, you got about 3 weeks.
Yeah, and I want you to come to the lab and demonstrate to you first
Okay.
before we go to him.
Okay. So how have you tried the software part yet?
We're gonna work on that. I'm gonna start working on that on Saturday.
Okay. The textbook for the HC12. I'm sure you guys got that right when you took microprocessors.
I turned my back in. I traded
Yeah.
my book.
Oh, I borrowed somebody's.
I have
You
one.
have it?
Yeah.
Okay.
I let
Okay.
Kelsey use it. I can get it from her.
Okay.
What's the name of the book? Because I can look to see if I have a copy of the book. Because all you really want to do is find the code. Don't waste a whole lot of time trying to understand everything about the microprocessor. You want to put the code in place. Once it does what you need it to do, and that's it.
He was saying that we had to activate something on the board. Is that saying we have to activate the A to D?
Well, yeah, that
Okay.
you have to do that anyway.
So that's what you're saying. Look for the code to activate the A to D.
Right. If you look in that book that I gave you, if
Yeah,
you look in that, right, it actually has the code because what have you guys know when you define these directives in the microprocessor, those directives set the address, everything connected to the A to D converter. So you got to initialize and set it all up, and then once it starts working, it'll start the conversion and then it'll bring in the values.
Is there a reason that you put the 2 inputs on the first 2 pins?
No, there is no reason.
Okay.
I just thought it made sense to use the first 2 pins because when you're controlling the multiplexer, you'll just go to one value and then to the next value.
I was just wondering,
No, it's just arbitrary. It could have been the first value and then the last value. It could have been. It doesn't really matter. And so when you look at a board, you should see the connections. You should see
I forgot to ask him about,
AN0 all the way down to AN.
how do we incorporate our mini project into our
See, so all you need to do is
final
choose 2
report that's due on the 12th? Let me ask her that.
And your software can specify which one you're using, so you know you're reading this one or the one below. And so that's it. Okay, so probably if I were you, somebody needs to start working with the software immediately because I guarantee you that's probably going to be the hard part.
Saturday. I'm all over it.
Because building something it has its challenges, but it's not as bad as software. Because software is not working, you don't know what's going on or what hardware, you say, okay, it's a bad resistor or a bad component or whatever. See, so if you guys do that. So when are you going to be ready, you think, for me to come over and take a look at what you have? And you don't have to complete the whole thing. For example, you can complete one of the analog parts, just that path, and get it working, and then I'll come and take a look at it before you complete the digital part. So you don't need the whole thing.
Well, I plan to have everything complete by Monday, and I was going to get
Not everything.
Professor,
Circuit
yeah, the circuit,
circuit.
my circuit, like the circuit part
Okay.
of it done
Okay.
on Monday.
I want to get that A to D thing done by next Monday.
Okay.
I want to have that tackled. So that gives me 2 Saturdays, this Saturday and next Saturday.
Right. I think if you start with some example code and just play around with it a little bit. Because what I would do is I would take that board, take like a sinusoidal input, and then have it convert. Because what you want to do is play around with it to make sure that it's doing what you think it's doing.
Right.
And then once you've done that, then you just tweak the code a little bit and you're in business.
Right.
Okay, now, I guess the part where you're going to interface to the computer, you're not going to worry about that part. 'Cause that's down the
If we
road.
get this working, we're gold. All we got to
Yeah.
do is connect another circuit to the ADD and then connect the ADD to the computer. All we have to do
Okay.
next semester is worry about waking up the computer if we get all this working. When we get all this working.
Right. There's no reason why you can't get it all working.
Right.
So, okay. I'll let you guys get out of here. Let me get back to trying to make this stuff